Hello and welcome to the screencast on the required practical of electrolysis, which is the last chemistry practical in C1. First of all, we're going to start with a retrieval practice. What I want you to do is write down the letters for each of the questions that are correct. So if you pause the video now, come back when you've answered the questions. Okay, hopefully you've been successful. Right, so what we're going to do is we're going to self-assess our work. Which of the following representations of an ionic compound is correct? Well, the first one is, because that is a representation of an ionic solid in a 3D giant lattice. The second one is a dot and cross diagram representing the electrons in the outer shell of both of the ions. However, the third one is not correct because it shows sharing of electrons, and that's covalent bonding. What two ways can ionic compounds conduct electricity? Well, they cannot conduct when they're solid, so that rules out A and B, but they can conduct when the ions can move, so that is molten and aqueous. What type of reaction is electrolysis? Well, it's a redox reaction because you have reduction and oxidation occurring, one at each electrode. What material can the electrodes be made out of? Well, that's carbon. Which of the following are ionic compounds? Now, ionic compounds will involve a metal and a non-metal. So A is correct, sodium's a metal, chlorine is a non-metal. Cobalt chloride, cobalt's a transition metal, chlorine again, non-metal. Lead nitrate, so you've got a metal joined with non-metal iron. And iron sulfate, a metal and a non-metal ion. Okay, so let's look at our success criteria for the lesson. We want to be able to recall what we've done in a previous screencast and predict the products at each electrode when aqueous ionic compounds are electrolyzed. So we're going to go over that. I will be able to describe how to carry out the required practical of investigating the electrolysis of aqueous solutions, and I will be able to deduce from various tests the product at each electrode when the aqueous solutions are electrolyzed. And if you're doing the higher tier paper, then there's a final success criteria. We have to be able to write ionic half equations for each of the reactions at each electrode. Okay, so let's make a start on our recall. What happens when ionic compounds are dissolved in water and electrolyzed? Well, in order to think about that, we need to think about, are there any ions in water? And there are. There are H plus ions, hydrogen ions, and OH minus ions, hydroxide ions. And it looks like this. Water breaks down into those two ions, H plus and OH minus. So, in an ionic solution, there will be four types of ion present. We've got the ones that we had when they were molten, the ionic solid, sodium and chloride, if we have a sodium chloride solution. And we've got the two from water, H plus and OH minus. So we have a situation where we've got two positive ions and two negative ions. And so when they actually move towards the electrodes, which they will do, there has to be a decision made on which one will actually be made into an element. So if we recall, the rule to predict the product at the negative electrode, the metals, it goes like this. So if the metal in the compound, like sodium chloride, is more reactive than hydrogen, so hydrogen is in red there, in the reactivity series. So any of these here, ignore carbon because it's not a metal, any of those, then hydrogen is the easiest element to be made at the electrode. So hydrogen will be made. Okay, so any above hydrogen, if they are in the ionic compound, you will make hydrogen. However, if the metal in the compound is less reactive than hydrogen, you will make the metal. So any of these four, if they are like copper chloride, you are going to make copper instead of hydrogen. So copper's easier to make than hydrogen. Okay, the rule to predict the product at the positive electrode, the anode. So if the non-metal in the compound is in group 7 or group 6, so that is, you would have a fluoride ion, a chloride ion, bromide, iodide, sulfide or oxide, then you will produce the element fluorine, chlorine, bromine, iodine, sulfur or oxygen. So if I had sodium chloride, because I have a chloride ion present and it's from group 7, I would make chlorine. Now if the non-metal in the compound is not in group 7, and usually we're going to be looking at an ending of the ion 8, which denotes oxygen is attached to another element, then oxygen will be formed. So the rule is it will either be usually a group 7 element made, if that's present. If not, it will be oxygen. So we're going to put that into practice now. What I want you to do is write down numbers 1 to 10 and write down what you think will be made at the negative electrode. So will it be the metal or hydrogen? And what we made at the positive anode, whether it's going to be oxygen or a halogen element. Okay, pause the video now. Okay, so let's have a look at what you've got. So for each of the solutions, write down the product. So potassium chloride, potassium is more reactive than hydrogen, so we're going to make hydrogen. We've got a halide ion present, so we're going to make chlorine. Copper sulfate, we're going to make copper, because copper is less reactive than hydrogen. And we're going to make oxygen. Zinc nitrate, zinc is more reactive than hydrogen, so we're going to make hydrogen. And we end in 8, so that means there's no halide ion present, and we're going to make oxygen. Silver chloride, we're making silver and chlorine. Silver bromide, silver and bromine. In both cases, silver is less reactive than hydrogen, and in both cases, we've got halide ions present. Calcium carbonate, we're going to make hydrogen because calcium is more reactive than hydrogen, and we're going to make oxygen because there's no halide present. Sodium nitrate, we're making hydrogen and oxygen again. Sodium chloride, we're making hydrogen and we're making chlorine. Copper nitrate, we're making copper and oxygen. And gold iodide, we're making gold and iodine. So hopefully you've been successful with that. If not, reread the last few slides before you proceed. Okay, so this means that we have successfully done our success criteria, our first one. We're going to move on to the second one, being able to describe how to carry it out. Okay, in this required practical, you would electrolyse 4 different ionic solutions and investigate the products made at the electrodes. So what I want you to do is draw a diagram of the electrolysis cell you would use and label it with these labels. So pause the video now and come back when you've done it. Okay, right, so the electrolysis cell looks like that, right? And the solution that we'd be using is in the beaker. So we've got our battery or power pack, which is our DC source. We've got our anode, which is the positive electrode, cathode, which is the negative electrode. We have our beaker to hold the electrolyte, the wires to carry the electricity from the power pack, and the electrolyte, which is our solution in the beaker. Okay, so our method, we're going to pour copper chloride solution into a beaker to about 50 centimeters cubed. Add a lid and insert carbon rods in through the holes. The rods must not touch each other, because otherwise we're eliminating the ions carrying the charge through the electrolyte. Attach crocodile leads to the rods. Connect the rods to the DC, the red and the black terminals of the low voltage power pack. We'll set it on 4 volts on the power pack and switch it on. Look at both of the electrodes. Is there bubbling at either? Is there any at either of the 2 of them, one of them, or both of them? Okay, because that will denote a gas being made. Use tweezers to hold a piece of blue litmus paper at the solution next to the positive electrode. This is the one connected to the red terminal. It is the one connected to the positive electricity source. You need to lift the lid temporarily to do this. After no more than 5 minutes, switch off the power supply. Examine the negative electrode, which is the one connected to the black terminal, the one connected to the negative electrode in the power pack. Is there evidence of a metal coating on it? And what do you think that could be in copper chloride? Okay, record your results in the table. After you've done that, clean the equipment carefully, because if you have had a metal made, then you'll need to clean it carefully off so you can observe the next few. We're going to repeat the whole thing again with 3 more solutions. We've got copper sulfate, which is our blue solution, sodium chloride, which is transparent, and sodium sulfate. So we're going to repeat it all again with 3 more solutions. This is the table that we would record our results in. Okay, so we're looking at our observation. Do we see bubbles? Do we see a colour? What is the result of any test that we do? And then what element do we think is actually being made based upon those tests? Now, before we can do that, we need to recap how we would carry out various tests. So there are 3 gases that we mentioned when we were talking about electrolyzing things: chlorine, oxygen, and hydrogen. So we need to recall how we would work out which of the transparent gases, the bubbles that are being made, how would we know if it was chlorine, oxygen, or hydrogen? And how would we be able to tell if we had got a metal that it was copper? So what I want you to do is pause the video now and come back, write down what you remember as the tests. If you don't remember, leave it blank, and then you need to learn the tests for various gases. So pause the video now. Okay, hopefully you've remembered those. So how can we test to see if chlorine gas is present? Remember, a test involves what we do and then what we see. Okay, so chlorine, what we'll do is we'll put damp blue litmus paper next to the gas, and the positive result for chlorine is it will turn from blue to white because it bleaches it. How can we test to see if oxygen is present? The test is we put a glowing splint into the gas, and if it is oxygen, it will relight. How can we test for hydrogen? Well, we put a glowing splint, sorry, I beg your pardon, a lighted splint into the gas and we get a squeaky pop. Now, lots of you will just write down squeaky pop test, but you must, if you want to get 2 marks, put a lighted splint into the gas and it will produce a squeaky pop. How can we tell if copper metal's present? Well, copper's quite a distinctive metal. It's an orangey pink colour. So if you get an orangey pink metal on the negative electrode, the cathode, then it is copper. Okay, so that is how we actually carry out the test. Now we're going to look to see if we, based upon observations, if you can deduce from those tests what the element is. Okay, so these are the observations that have been made. So copper chloride at the positive electrode, we've got bubbles of gas that bleach litmus. And at the negative electrode, we've got a coating of a pinkish metal on the electrode. Copper sulfate, we've got bubbles of gas that don't bleach litmus, but they will relight a glowing splint. And again, we've got a pinkish metal on the electrode. So you read through this and come back after you've paused the video and you have tried to predict what the elements are, and then you can restart the video. We'll go through the answers. Okay, welcome back. Right, so let's go through these answers and we'll self-assess. So bubbles of gas that bleach litmus, that is chlorine. Coating of pinkish metal on the electrode, that is copper. Bubbles of gas that do not bleach litmus but relight a glowing splint, that is oxygen. Coating of pinkish metal on the electrode, again copper. Sodium chloride, where we've got bubbles of gas that bleach litmus, so again we've got chlorine. No metal on the electrode, but the gas produced gives a squeaky pop, that is hydrogen. Bubbles of gas that do not bleach litmus but relight a glowing splint, oxygen. And no metal on the electrode, gas produces a squeaky pop with a lighted splint, hydrogen. So hopefully you've been successful with those. And that's our third success criteria. Now, if you are on the foundation tier, you don't need to carry on with this screencast to answer your questions. If you're doing the higher tier, then we'll carry on. We need to be able to write half equations for the reactions at each electrode. Okay, at the cathode, if you remember, we have the cation, which is positive. It receives electrons from the cathode and it becomes an element. Okay, so however many positive charges it's got, that's the number of electrons that it needs to receive in order to become an element. So for instance, sodium 1+ will need 1 electron to become sodium. So Na plus E- gives us sodium. Cu2 plus 2 electrons gives us Cu. Al3 plus 3 electrons will give us Al. And 2H plus 2 electrons will give us H2. Now you notice that we've had to have 2 H pluses because hydrogen as an element will go around as a diatomic molecule. That means 2 molecules together. Non-metal ions are negative because they have extra electrons. When they reach the positive anode, they give up an electron, making them neutral. So here's our example. 2 Cl minus. Again, we're going to need 2 because chlorine Cl2 goes around as 2 atoms together, a diatomic molecule. And at that stage, we give up 2 electrons to the anode. 2 Br minus will give us Br2 plus 2 electrons. Now, we did mention that when oxygen's made, we've got a little bit more complicated ionic equation that we do need to learn. So it is quite difficult, I know, but you need to learn this off by heart. So 4OH minus will give us 2H2O plus O2 plus 4 electrons. There's nothing we can do to actually help you remember that. We just need to learn it off by heart. Okay, so we've done the predicting what we're going to be making. Now we need to try and write the balanced half equations. So remembering what we've done in the previous 2 slides, I want you to pause the video now and attempt the half equations. Okay, welcome back. I know that these are difficult. People usually struggle with them, but especially the negative electrode, they should be quite straightforward. Okay, copper chloride, we're making chlorine. So we've got 2 Cl minus gives us Cl2 plus 2 electrons. The copper is Cu2 plus 2 electrons give you Cu. For copper sulfate, we're making oxygen. So we've got that equation that we need to learn. 4OH minus gives us 2H2O plus O2 plus 4 electrons. And again, for the copper, Cu2 plus 2 electrons give us Cu. Chlorine, again, 2 Cl minus gives us Cl2 plus 2 electrons. And the hydrogen, 2H plus 2 electrons give us H2. Oxygen, 4OH minus gives us 2H2O plus O2 plus 4 electrons, and hydrogen, again 2H plus 2 electrons gives us H2. Okay, I hope that you have been successful and you've understood this. If you haven't, then have a little run through again before you answer your questions, and or else consult your teacher. Okay, see you later. Bye bye.